Graph Theory, Class 7, Video 1. In this video we're going to introduce the concept of a planar graph. Let's begin with the definition. So the definition says, a planar graph is any graph that can be drawn without edge crossings. And the most important part of this definition is this word can, okay? I'm not saying that every possible drawing has to be without edge crossings. I'm just saying that it's possible for someone to redraw the graph with no edge crossings. So just because a picture of a graph which I give you happens to have edge crossings doesn't mean that it's necessarily non-planar. It might be possible to redraw it in a way where there are no edge crossings. Okay? So the important part of this definition is that you can redraw the graph without edge crossings. This is the notion of a planar graph. So let's do an example. Okay? Really simple, straightforward example. Show that the following graphs are planar. So right now, this has an edge crossing right there. That's an edge crossing. But that doesn't necessarily mean that this graph is non-planar. It just means that this particular way of drawing it has an edge crossing. But there might be another way of drawing this graph without this edge crossing. I mean, what I could do is I could, for example, take this edge here and try and stretch it. So instead that it goes over the top. Okay, so let me redraw this graph. It has to be the same graph, right? It has to be isomorphic to the original graph. So I'm just going to redraw it. But now, instead of drawing this edge like this, I'm going to take it around the outside. And these two, they're the same. They're isomorphic graphs. But on the right, there are no more edge crossings. You notice that on the left, there was an edge crossing, but on the right, there is no edge crossing. And that shows that the graph is planar, because I can draw it without edge crossings. Let's move on to the second one. Okay? So the second example has lots of edge crossings, like so many edge crossings. Okay? Has all of these edge crossings. So I need to fix all of these. I need to redraw this graph and eliminate all of these edge crossings. And there's not really a secret method for doing this which always works and is easy. A lot of the time it's a bit of trial and error. You have to try and stretch and pull some of the edges so that they no longer cross. But another technique is, instead of only moving the edges, you can move the vertices as well. Okay? There's nothing wrong with moving the vertices. So if I have this graph down here, what I might do is I might take this vertex and just move it to the right. And I'm not allowed to break any edges or anything like that. So what happens if I do that? So I have that vertex, them, and I just moved it to the right. And I'm going to redraw all the edges. And it's nice and simple. It's like this. Okay? These two graphs, they're exactly the same graph. Mathematically, they have the same vertices and the same edges. So they're exactly the same mathematically, except the one on the right I've drawn without edge crossings, whereas the one on the left did have edge crossings. And the fact that it's possible for me to draw it without edge crossings means that it is planar. Okay? So that's the end of this example, and that's the end of this video.